Hello and welcome to this Unity Catalog introduction. My name is Youssef Mrini, and I'll be your host today. Let's get started. So, by the end of this session, you will be able to describe key concepts related to Unity Catalog, manage users and groups, create Unity Catalog-enabled cluster and SQL endpoint, create and govern table and views, govern file access, limit the table access with dynamic views, and the lineage. But before, let's have a look at an overview of Unity Catalog. And before we dive into the specs of Unity Catalog, let's take a moment to discuss the more general topic of data governance. Data governance really refers to the process of managing the availability, usability, integrity, and security of data. Data governance has become extremely important in today's data-driven landscape and is needed to establish trustworthy data that is really accessible to those who need it in accordance with internally defined policies or externally regulatory requirements. When we talk about data governance, we can generally divide discussion into four main areas. The first one is data access control. And data engineers and platform admins need to be able to lock down data and data generating artifacts such as files, tables, models, and permit access to only those who need it. We have data access auditing. And of course, any data governance program requires knowledge of how data is being used, not just who has access to the data, but when and how it's being used. And the data lineage and the journey of your data takes from its origin, and as it moves through your pipelines, it's referred to as a data lineage. And being able to retrace it is very beneficial in a number of ways. First, it's much easier to identify root cause of processing issues, enable you to predict the impact of proposed upstream changes to your processing, helps compliance team prove that that data and reports come from like trusted and verifiable sources. In short, it fuels better understanding of the data for data analysts, data scientists, and data engineers. And last but not least, data discovery, which is very, very important because we need to locate data. When it comes to locating data, it's very, very important. But a data governance program requires a readily accessible inventory of data assets. And Unity Catalog allows you to define access rule once, where they can be like applied across multiple workspaces, clouds, languages, and use cases, governing all your data assets in a consistent way through easy-to-use interface and SQL APIs. The access controls available go far beyond what any cloud system can provide. And while your data is free to roam, Unity Catalog can manage it from all a central hub in a consistent and familiar way. There is no need to replicate or translate your security requirements across different systems. If rule changes, they only need to be applied once. And Unity Catalog brings also with it the ability to do a fine-grained audit of all queries performed to support data governance use cases. And data lineage will also be collected and visualized for tables and columns across all languages. And of course, this feature is GA right now. And Unity Catalog is additive and works seamlessly with other metastores, including the legacy Hive metastore built into each Databricks workspace, which of course many of you have taken advantage of. And through the three-level namespace we will cover shortly, you can have seamless ongoing access to your existing data, while it makes it a lot sense to upgrade your data to Unity Catalog as soon as you can. And there is no hard requirements. Upgrading data to Unity Catalog is a simple operation that can be done whenever you like. And today, As I mentioned, we're going to discuss the key capabilities of UC and some of the broader pattern changes that UC is bringing as a service and paradigm shift bring to the Databricks ecosystem. So some of those will include like the centralized metadata and user management, centralized data access control, data lineage, data access auditing, data search and discovery, and of course, not now, but secure data sharing with data sharing. And how does Unity Catalog fit into the Databricks landscape? So here on the left, we see an overview of how things looked prior to Unity Catalog. And prior to Unity Catalog, user management and data management were a function of the workspace. And the workspace admins defined users and groups within a particular workspace, either manually or through a connection to an identity provider or of some sort. But the key point here is that users and groups are ingrained into a single workspace with no interesting synchronization in multiple workspace environments. And governance was provided by a cooperative effort between a metastore and the compute resource accessing the data. That is clusters and SQL endpoints. The metastore by default was a local Hive metastore, although of course we did support external metastores. And one key element to note here are the locality of the metastore, which makes it challenging to easily, consistently apply the same set of security controls across multiple workspaces. Furthermore, the full security requires cooperation between compute resource and the metastore. And if compute resources are not appropriately configured to enforce access controls, then access rules can be bypassed. And by contrast, Unity Catalog, with its enhanced security model, sits on its own factor, the security-related elements out of the workspace, enabling the define once principle we discussed earlier. In this architecture, account administrator manage the users either manually or through a connection to an identity provider of some sort. They also manage the creation of metastores, each of which, of course, contain metadata and access control list. Users, groups, and metastore can then be assigned to workspaces as well. And compute resources that can connect to UC will be by default be subject to UC security constraints. No specific configuration or administration is needed to make the system secure. And as can be seen, security policies define a metastore in a metastore are automatically and immediately propagated to all assigned workspaces. And now that we understand some of the benefits UC brings, as we all how it is fit in the rest of Databricks, let's take a look of some of the key elements out of the Unity Catalog metastore. So the metastore is really the top level container of objects in Unity Catalog. Accounts admin can create and manage metastores and assign them to Databricks workspace to allow like workloads in those workspaces to access the metastore. And the metastores stores secureable data assets as well as the permissions that govern access to those assets. It is important to not confuse the UC metastore with the Hive metastore. The Hive metastore, which you are familiar with, exists in the local metastore linked to each Databricks workspace and also provides data storage and access control capabilities. We have, of course, within the Unity Catalog metastores, we have one or more catalogs. And a catalog can contain database, which also referred to as schemas, that are connected to UC. Also present, of course, in this catalog, we have the legacy Hive metastore under the name Hive_metastore. And deeper, like diving deeper in the object hierarchy, we have the database, also, as I mentioned, referred to as a schema. This concept will be familiar to most of the concepts are unchanged in UC. Then we have a view at the very bottom of the hierarchy within the database. We find our data assets like bearing asset, table, and views. The concept of the view is unchanged. It can be thought as a read-only virtual table that is executed when you query it. And of course, as we mentioned, Databricks support true table variation, managed, and external tables. So let's discuss a bit. So we have the managed, and the managed tables are the one that are stored where the data is stored in the your ADLS or your S3 bucket, which means Databricks manage the location. And what we have added recently is possibility to define the location of this managed table. The only thing you should keep in mind is that managed table supports only delta tables. This is very, very important. And we recommend you to use managed tables because you don't have to define permissions like storage credential and external location. But in the other side, you can also use the external tables. And the external tables are also like tables where we're going to define, of course, the location, which means this can be another data lake. Of course, you need to define storage credential and external location, and I will give you some details about it. And in contrast, external table supports like several formats like CSV, Parquet, and other things. And there's also a key difference between those two is that in external table, if you drop the table, you only drop the registration in the metastore, and the data will still reside in the external table. And I will do a comparison of those two tables within a few minutes. And then we have something very, very important called storage credential. And you need to define the storage credential whenever you have an external table. And the storage credential encapsulates an authentication method to access the cloud storage. And we have also the external location that also need to be defined. And this external location combines a storage credential that we have defined previously with a cloud storage path, providing an object that is fully describes an external location, including a way to access it. And this is very, very important. And this is just a comparison between those two tables. So for both tables, the metadata lives in the control plane. For the managed table, supports delta only, while for the external supports several formats. Dropping data in managed table discards data, while for the external drops leaves the data intact. And of course, data lives in metastore managed by storage location for managed table, and data lives in a user provided storage location for the external table. And the question when to use external table. So it's quick and easy, from external table in Hub Metastore, when we have external readers or writer, when it requires, a specific storage, naming, or hierarchy, when you need this infrastructure level isolation requirement, and of course, when you can't have a delta support requirement. And regarding the tree-level namespace, so as I mentioned prior to UC, a workspace was effectively a logical point of data segregation. With UC, we need to add an additional layer of data segregation. So we added this third-level namespace called a catalog. So a catalog, as I have mentioned previously, is an object that contains databases, a database like you are familiar from Hive and traditional RDBMS contain views and tables. And we have also data access control, which is gonna let you, revoke, grant the access. You can do it either through the API or through the UI or through Terraform. So you can grant permissions over a catalog, over external location, create share, schema. You can define every permission. And as I mentioned, you can either do it through the API through the SQL through the UI, as you can see in the screenshot, or using like ANSI. And this is ANSI SQL, and this is just an example, like grant select on, I don't know, event, for example, to engineers, which can be a group or to a specific user. It's really up to you to define how you can do this. And regarding like the new compute resources, so we have the first type, which is a single user. And as the name suggests, cluster using this mode can only be used by a single user who is designated when creating or editing the cluster. Others, of course, cannot attach this cluster to their notebook. So this apparent disadvantage is encountered by the functionality that make single user cluster supports SQL, Python, Scala, and R workloads. And we have the second type of cluster, which is shared. And it's the shared cluster, of course, can be used by multiple users. And for now, it supports only SQL and Python. And tables in UC. So as I did mention, before we had this traditional two-layer namespace, now we have this three-level namespace. So before it was schema.table, now we have the catalog.schema.table. And this is just, I'm gonna just a brief summary of how table access control works in Unity catalog. So let's suppose you wanna access to give someone a permission or a user permission over a table. You need to be to grant him the usage over a catalog, the usage over a database, and then deselect over this table. If you want him, for example, to update this table, then you need to grant him the modify over this table. If you want him to create another table, you need to grant him the create over the database. And if you want him to create a database, you need to grant him the create over the catalog. And of course, just a brief summary. We have two types of tables, as I have previously mentioned. So we have the catalog. When it's managed, you just need to define the managed table. When it's an external, then you need to define what we call the external location and the storage credential. And as I have mentioned, like this storage credential, just when you like grant, like it's to connect to enable UC to connect to this external cloud storage. For, as I mentioned, it's equivalent of IAM role, for example, for S3. And for the external location, it's just the storage credential plus the cloud path. And of course, over also those external locations and storage credentials, you can define permissions like create table, read files, write files. And we have views. And views are very, very important in Unity catalog. So just keep in mind, when you're creating a views and you're gonna do like data masking or anything else, make sure to use shared clusters, because if you use shared clusters. So let's suppose you wanna create a view. So you just need to have the select over, to access a view, you need to have the select, of course, over the specific view. And to create a view, you need to have the possibility to create to create over the database. And we have multiple options with the views. So we can do like limited access to columns or limit access to rows, or also do data masking, which is very, very important. And for data lineage, which is, I think, one of the most interesting features also in Unity catalog. So the lineage is, as I mentioned, pretty exciting. So you have the ability to automatically capture runtime lineage on clusters and SQL endpoints down to the column level. So that means that if you create like derivative data sets based on another data set through the Spark APIs, you will see this relationship in the UI. And so how does it work? So we have this service lineage. So it captures either like tables created through like either your ETL, job, or ad hoc. And this is captured, and then everything is written there, and you can explore this UI in the lineage in the UI. And how it goes. So before spouse goes off and paralyze this operation, so to its worker node, it creates something called a logical plan. And this is, let's say, an abstraction of all transformations in linked graph form. And the metadata of these objects gets submitted to a lineage service. This runs, of course, in the control plane, and this service assembles all of the logical plans for all the commands together to create the lineage graphs that can be boiled down into this tabular information about what tables fed into another tables and what columns fed into another one. And now let's move to the demo. So just to show you, as I mentioned, the compute. So you can have single user and shared. So single user, as you can see, you have this Unity catalog tag. Same thing for the shared. If you choose like no isolation, you see that there is no UC tag. So let me just go to Unity catalog. I'm just going to see in case. Okay, I think the cluster is on. So the first thing we're gonna do, I'm gonna create a catalog called demo_UC. So I'm gonna create the catalog and I'm gonna use this catalog. I'm gonna also create something like a database called a boat because I'm gonna use Titanic dataset. We're gonna also use this boat. And then the first thing I'm gonna do, let's suppose I have a dataset in the legacy Hive metastore, which is hive_metastore default parquet. So to migrate my data, for example, to Unity catalog, I can just run this parquet, create table, demo to this demo UC boat. I'm gonna call the table Titanic_v1, and I'm gonna feed it with this data coming from this specific table. And once this table is created, I'm just gonna run this describe extended, and you will see that I'm gonna create my first managed table within Unity catalog. And of course, the format, as I mentioned, managed table supports only delta tables. So this is the information up, and you see type manage, and of course, provider delta. If somehow I want to create a parquet table within my managed tables, you see I will have an error tell me only delta is supported for managed tables. And if I have, for example, a delta table in my Hive metastore, I can also run a clone. Instead of like running create set as, I can use a clone. And here you see I'm going to create this Titanic V2 div clone. And of course, within UC, whenever you create a table, no permission is granted. So what I can do, I can either like grant permissions through the SQL API. And here we have something called the, like here, I'm gonna grant all privileges like on catalog. And there is what you call now inheritance, which means if you grant permissions to a catalog, it goes through like the database and table, or you can grant permission on each layer. So for my case, I'm gonna grant all permissions. So now I can show you the permission over the catalog. So show grant, you see all privileges. We're gonna show grants on the schema again, and so show grant on like a specific table. And if I go to the data explorer, I can click on data, and I will select, of course, my catalog, which is demo UC. You see both. I can, when I go to demo UC, I can grant over here the permission. You see, I can grant like custom permission to a specific user or group. I can select either all privileges or a specific one. So it's up to you to decide whether we're gonna grant those permissions within the UI or within the API. And now if I want, I can now query, like say my first table. And when it comes to, this is when it comes to manage tables. When I wanna like create external external tables, I need to define first this storage credentials. So I need to create this storage credentials. So we see here, recommended is managed identity. So I need to specify the storage credential name, the access connector ID. And I also need to specify the external location. So I can specify the URL, specify the storage credential I have created, and some comments if I want to help, for example, the team. And for my case, I'm gonna use this external. I'm gonna show all the external locations I have over here. So for my case, I'm gonna use this one. But what I need to do first, I need to grant myself the some permissions over the external location to be able to. I'm gonna grant myself the permission over this one, all privileges, and I'm gonna just okay. So now what I'm gonna do, I'm gonna just my bad. I'm gonna describe the first external, and I'm gonna again show all the storage credentials. I'm gonna use, of course, this one. You see external. You see they can have details about who created and when. And now what I'm gonna do, I'm just gonna show grants over this external location. So you see I already have the access, and I'm gonna also show grants over this storage credential, and I need to change it. Yeah. And now I wait. Okay. There is always a bug, of course. Okay, okay. Does not exist. Ah. Okay, let's do some debugging. So this is the storage credential I have mentioned. Okay. Ah, I was copy pasting on the wrong one. Okay. My bad. I got lost. Let's fix this. Okay, I was doing the wrong thing. So now what I'm gonna do. So let's. This is of course demo H-Live demo issues. Let's now. I'm gonna create my first external table. I'm gonna call it Titanic external. I'm gonna specify the location, and then I'm gonna say, okay, select count passenger ID. So when it's survived equal to 0, then dead, else survived. So I'm gonna create a new column called status. And I'm gonna compute this first external table, and I'm gonna do this describe external. Okay, so it's this, you see type external, of course, this is delta. And if I want to create like the same, another table, but this one is external, but this time is parquet, I can also create a parquet. But before, you see, I need to drop, because if you're using an external table, like the all the other formats supports only appending data. If you want to, the override works only if you are using a delta table. So now I just needed to drop the data there. And now you see describe extended, I can have access to my parquet table. And now that I have created this table, so you see that I have some specific, let's say, a relationship between those two tables, because I created this Titanic, this Titanic external based on this Titanic V2. So what I'm gonna do, just gonna go to data, I'm gonna go to demo UC, vote, and I have Titanic external. So here I can click on lineage. If I click on lineage, so you see that I have created this Titanic V2 based on Titanic, create Titanic external based on this Titanic V2. And you see, this is very, very important. You can also see that I created another one, which is Titanic external parquet. And that's not everything. So you see, I created the column status, which is whether this passenger is dead or alive. So you see status, it shows that has been computed from the column survived. So this is really how this lineage is very important. You can also see where this table is called in which notebook, if this table is on a specific workflow, whether upstream or downstream, and if this table is called on a dashboard. And this is super important. And you can also like see frequent queries. You see all the different types over here, and again we can grant the permission. And also, as something I mentioned, I didn't show you. So you can also click on over here, and you can see like whether there is lineage or not. So this is super important. You can also export this lineage with the API. And of course, that's not everything. So let's suppose now you wanna grant some. I'm gonna create some views. So we're gonna first of all try this column level permissions. So over here, I'm gonna create a view called Titanic redacted, and I'm gonna specify, like, select the number, and then say, okay, if I am part of this group, then I can see the gender. Else, if I'm not part of this group, which is EMEA, then I will see only dashes. And that's it. So I'm gonna run this query right now. And because I'm not part of this group EMEA, so you see, I want to be able to view this specific column. And this is when it comes to column level permissions. For a row level permission, so I'm gonna create this Titanic redacted row. I'm gonna select like data from this specific table. And then I'm gonna specify a condition. If I'm part of this group, I can see everything. Else, I will only view where the number is lower than 5. So I'm gonna run this view. You'll see I will have only one row. And I'm gonna create again the same view, but this time I'm gonna mention a group where I exist. So I'm gonna, with the same query, only change the group. So if I run the second view, you will see I can view everything. So this is how we can do column row level masking. And something also which is very important, with delta tables, now you have the possibility to create what we call primary keys and foreign keys. Just keep in mind that those primary keys and foreign keys won't enforce integrity, but they are declarative. They will help you to create your data model within, for example, Tableau or your Power BI or any other connector supports Unity catalog, and also helps like the data analyst or data engineer to understand the relationship between tables. So here I'm gonna create, for example, table persons, gonna constraint persons PK. So I'm gonna specify primary key, those two primary keys, and I'm gonna also create like table pets, the constraints, and I'm gonna specify the foreign key. So now that I have created those two tables, if I go to data, demo UC, I go to features. Now, if I click, for example, on persons, so we see primary key. If I click on pets, it shows like primary key references table persons. And this is very important. And you have also something you can leverage called information schema. And this is where you can find everything you have defined in your within Unity catalog, like constraints, reference, everything. Like super interesting. And you can also grant permissions if you want over here. If you go to like the meta store permissions, without having to access like the what we call the account console, you can, for example, grant permission to someone to, for example, to create a catalog, to create an external location, to create like a provider, and everything. So UC is very important. It has also a super great integration with SQL. So whenever you create, for example, a warehouse, SQL warehouse, you will see that you can activate, enable UC or not. By default, UC is enabled, and you can access the same. And you can own something important. You can only have one metastore per region and one metastore assigned to a specific workspace. So thank you for attending this session. See you soon.